It's really important that you can do these rates of change questions on your calculator. So I'm going to show you how to do this particular one on the Ti84.
First of all, I'm going to enter the first equation, which models the ball being thrown in its height. So here I'm going to put negative 4.9, use x squared plus 19.6 x plus 1.4. Now I'm going to go to table set. So this one here, second table set. I'm going to make sure that I'm starting at 0, and I'm going to tell it that I'm going to ask the independent. So I'm going to give it the independent, which is the x value, and then it's going to give me the y value. The reason I put ask is because I don't need a whole load of values. I just need some specific ones. Then I go to table, and the first one is find the height of the ball when t is 0. So press 0, and the height of the ball is 1.4 meters. And then it says, what is the height when it's 2 seconds? So press 2, and the height is 21 meters. The next question says, find the average rate of change of the height of the ball from 0 seconds to 2 seconds. So that means I need to find the gradient between these two. So I'm going to find the difference in the rise, which is the difference in these two, over the difference in run, which is just 0 to 2, which is 2. So come out of that, and it's 21 minus 1.4, and divide that by 2. And this gives me the rate of change, 9.8 meters per second between 0 and 2 seconds. Now, C asks for the instantaneous rate of change at t is equal to 1, 2, and 3 seconds. So then I need the gradient function. So I'm simply going to put in the equation as y2. So first of all, I'm going to press math. That's this one here, math. And then I'm going to go down to number 8, which is, it says the n derivative, right? And that I'm going to press enter. And then I'm going to tell it I'm doing the rate of change of x. And here, if I press alpha calc, it's going to give me the option of using that equation. So alpha calc, and I want this one here, y1. So I'm going to press enter. And then here I want x at every value, so just put x. Now when I go to my table, you see I've got the y2 value here. So what is the rate of change when t is equal to 0? It's 19.6. Actually, it's not asking me that. It's asking me t is equal to 1. So press enter on 1. It's 9.8 meters per second. T is equal to 2. What is the rate of change there? 0. That's very interesting. It means it's not moving. And then at 3 seconds, it's negative 9.8 meters per second. Well, and then it says, can you explain these values? So what must be happening is the ball's going up at 9.8 meters per second, and then it's at rest at the very top before it changes direction, which is then minus 9.8 meters per second at that exact precise point when t is 1 second, t is 2 seconds, 0, and t is 3 seconds. And that explains that. So really make sure you use this, make use of this table set. It's very important to save you a lot of time.